This is Matt Beattie, and in this video, I'm going to show you how the second phase of Project 1 worked, which would be the unredaction routine, which is significantly more complicated than the redactor routine. So what we're going to do in this video is we'll start off with a review of the program by taking a look at the README file first, since we actually did run the PyTest once in our previous video. So we'll take a look at that. The first section of the README file has to do with things that we discussed in setting up the module and redactor, which we discussed in the first video. So we'll get to Unredactor. Unredactor is extracted in the same tarball that redactor was in, and it's called in a similar fashion. It's got several different options. It's got the input directory, the output directory. This is very important. It allows you to use a pickle file for the classifier, because creating the classifier takes quite a bit of time. The classifiers that I use in this, to create the classifiers in this project, I use the scikit learn package and 3,000 training files and 3,000 test files. It takes quite a while to create those classifiers, so we save them as pickle files. This enables us to take a redacted file and unredact it without having to wait for the creation of a classifier. Then for situations where we're not using the pickle classifier, we can use options that give us the number of training files from the IMDb dataset and test files from the IMDb dataset that we'd like to use. The way it works is it seeks to unredact proper person names by using a classifier that was built based on the IMDb files. Now, there's going to be an inherent limitation here, because the only names that it finds in the IMDb set would be those of movie stars. So we would expect the classifier to replace any redacted name with a movie star's name. There are two classifiers that are built in the program. One's a naive Bayes classifier. The other is a decision tree classifier. I had a lot of difficulty in building a support vector machines classifier, so it's not included here. And I'm using two features. The first feature is the value of the review, which is extracted from the name of the review itself, and then the length of the name that has been redacted. So those are only two features. There are many more features than could be used here, but I found, quite frankly, that the time associated with building the classifier with just these two simple features was pretty long. The program doesn't perform very well. It's not terribly surprising, because we're only using two features for each redacted word, and there are thousands and thousands of potential names. As a matter of fact, there are more potential names than there are files that we used for the classifier building. The best performance I got was 1.08% by the decision tree model. We're using 3,000 training and 3,000 test files. However, while that's low, if we were to randomly choose a name out of the 6,000 possible names that are available in the data sets, we would get less than 1/100% chance of making that happen. So we can see that we did see about 100-fold improvement in our chances of getting a name by using this classifier. So not too bad, but doesn't make for a very useful unredactor. I printed out the results that I saw here. I used 1,000, 3,000, and 5,000 test and training files, and in each case, the decision tree classifier outperformed the Bayes classifier, and again, the best performance I got was the decision tree classifier, which was correct 1.08% of the time. I also included here the amount of time that it took to build the classifier. This is in CPU seconds, so it doesn't represent the actual amount of time it took the program to run. But as you can see here, the time included increased pretty significantly as we increase the number of files that were included. I tried increasing the number of CPUs to improve the performance of the machine, but what I learned along the way is that native Python doesn't take advantage of parallel CPUs. You have to include routines to run processes in parallel, which seemed to be pretty difficult. I actually tried that. I had a fair amount of problems doing that. And so the best way to improve this program would be to increase the number of features that we use, change the classifying sets to include other proper nouns as a vectorized dictionary of potential words. And also, we'd run this routine on a Spark cluster if we really wanted to get better performance. So that said, let's take a look at how things work. We will skip the PyTest since that was in my first video, and as we saw, actually, I take that back. Let's go ahead and do it. So we can see where we're going to fail. The redact, again, these are the where the routines that pass were the redaction routines and the feature extraction routine in the unredactor set. But as you can see, it failed in terms of unredacting a name. So the PyTest that was included, you can see here, was a test where we seek to unredact this string. A great actor is thorn, 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 and give it a file. And what we wanted to see was a great actor is John Wayne, I think. And instead, the unredactor produced the formal name Ballantyne, which had the same number of characters as John Wayne, but of course isn't John Wayne. So the test fails. So again, since it only worked 1.08% of the time, it's no surprise that PyTest fails. We can take a look at our documents here. You can see these are the IMDb movie files, and the last digit of the first 4 digits is the value of the review. So we'll just take a look at the, let's see, we'll do a random one here. Let's take a look at 4366. We can see the name of the movie, Killjoy. Here's the name, singer Olympia Fernandez. And we'll see if we can find that one. So the first thing we need to do is we actually need to redact these files. So we produce the Thorn characters. We'll put the output documents in the same place. And we will redact the names. And so you can see it treats everything as a glob, goes in and does the redaction. We'll just double check our work. And we can see that Olympia Fernandez has indeed been redacted. You can also see that the program saw the title of the film as a formal name because it found it as a capitalized word, which is a feature of NLTK. So it's going to try to unredact that, even though that's not a person. So now we'll go ahead and run Unredactor. So it'd probably just be easier to do this. Names option. And we'll just change the word redactor to unredactor. and let it go. And we're going to stop it because it's training. Actually, you can see, you know what? It's okay. We can kind of let you see how it works, but we're going to stop that program and we're actually going to use the training file. So we'll make sure that we didn't overwrite it, which we didn't. There's our there's our decision tree classifier. Let's add that in as an option. So we'll go back to our docs file and take a look. You can see that it created a whole bunch of unredacted files here. So let's take a look at the one we just looked at. And we can see that we come up with some weird results. So it replaced the word Killjoy with Richie. We know we had Olivia Fernandez, we have Richie, and then we have Richie Bill Moon Pictures. So Unredactor definitely struggles to come up with the correct names in the redacted files. So again, the way to improve performance here would be to change the number of features that we got and change the way that we execute the program to write a more robust classifier.